Hello, everyone, and welcome to section 3.4, using the quadratic formula in Algebra 2 Honors. So the phrase that I really want you to memorize this year is, if you see, can you finish this yet? If you see an x squared in an equation, what do? Set it equal to 0 and factor. This is going to be what you do 90% of the time. So I see an x squared in my equation, I set it equal to 0, and I factor. But there's going to be times you can't factor. So last class I taught you something called completing the square, but I might have also mentioned that you really don't want to do that if that middle term there is odd. It's a little bit of a pain. So your third plan of attack is the quadratic formula. It's not terrible. It's just a formula. You just have to memorize it and use it. And you'll use it a lot. But you do want it to be your last resort. It is definitely more work than factoring. So this formula says that if you have the equation ax squared plus bx plus c is equal to 0, see, notice it has to be set equal to 0, then the answer, just jumping straight to the answer, will be negative b plus or minus b squared minus 4ac all over 2a. Although I will tell you right now that some people get this wrong, and so some people choose to write it this way to make sure that they reduce the 2a correctly. You know, if people see a 4 and an 8, they'll reduce them, but you can't because of that plus or minus. So if you want to, you can separate it into two fractions, and then you can simplify. So let's do one together. So I have the right format. I tried to factor and I couldn't. I'm not going to use completing the square because this is odd. So I just use the quadratic formula, which jumps straight to the answer. This is A, this is B, and this is C. So negative B plus or minus the square root of B squared minus 4AC all over 2A, which is negative 3 plus or minus the square root 9 plus 20 is 29 all over 2. How do you like that? Not too bad, right? All right, let's do another one. So my first step is to always set it equal to 0 and factor if I can. So I'm actually moving everything to the other side because if I do think I'm going to factor, I'm going to do it with a positive x squared. Even though I moved two things, I still think it's easier. 13 only has one choice, 1 and 13. And those will either make a 14 or a 12, but never a 4. So I know I can't factor. I could complete the square on this one. That would be a great way to do this. But today we're practicing quadratic formula. So x is equal to opposite of b plus or minus the square root of b squared minus 4ac all over 2a, which is equal to 4 plus or minus the square root, and get my calculator out here, 16 minus 4 times 13, negative 36, all over 2. This is where I was talking about. Do not cancel those. Okay, they do not cancel. X is equal to, you can put them separately, which is a great idea. The square root of negative 36 is 6i. And then you get 2 plus or minus 3i. And that's the answer. Now, I do feel just a little bit compelled to show this to you as completing the square, just so you can compare now that you've seen the quadratic formula. So if this were me, I would actually move the 13 over. So negative 13 is equal to x squared minus 4x. I complete the square by taking half, writing my square, And then now I know what I need to add to both sides, which is a 4. So that gives me negative 9 on this side. Then I square root both sides. Square root of negative 9 is equal to x minus 2. I add the 2 to the other side, and the square root of negative 9 is 3i. I have to tell you, I love that method. I think that that's faster and easier. This, I had to get out my calculator to do the b squared minus 4ac. But you do what you want. I always use the quadratic formula if it's not factorable and if this is odd. But if this is a nice even number, I kind of like completing the square. You'll find your way. Okay, but no matter what method you choose, the first step is always set it equal to 0 and factor. So I subtract and I get minus 20x and then plus 4. So I am going to just quickly try to factor. Those are big numbers for the quadratic formula. I try 5 and 5. I try 2 and 2. And look at that. There's no way quadratic formula was faster here. If they're both negative, and can they both be negative? Yes, that'll give me a positive 4. So this needs to be your first approach. It'll just be so much easier. And when I see this is, remember we talked about this? This is having an x squared term without an x term. You definitely don't want to use quadratic formula here. Add the 5 to both sides. Isolate the square root. You get plus or minus the square root of 6. And x is equal to 1 plus or minus the square root of 6. Minus 1 plus or minus the square root of 6. Okay, let's see that one by quadratic, unless I've convinced you, and then you're welcome to fast forward. But look at this. X plus 1 times x plus 1 minus 5 is equal to 7. 2 times x squared plus 2x plus 1. I'm going to bring over the 7. 2x squared plus 4x plus 2 minus 12 is equal to 0. And 2x squared plus 4x minus 10 is equal to 0. You could divide everything by 2 to make the numbers smaller, and it's a nice way to decide if you can factor, which now I know I can't. With the 2 and the 10, I might have considered more choices, but now that it's simplified, I realize that that 5 and that 1 are my only choices, which is either going to make 6 or 4, but never 2. So now I can use the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac. Are you seeing how long this is? I cannot stress enough to you that finding the best, most efficient method is pretty much the only way you're going to pass my tests. The tests are long not only because I want to make as many problems as possible so that you can have them each be worth less, but also so that you can look at a problem and say, I won't finish this test if I don't know the best way. So when you're starting out, you got to think, set it equal to 0 and factor. If you see this form, you need to take this shortcut, because if you're expanding and then using the quadratic formula, you are doing too much work for the exact same answer. Okay, so I'm just going to put up a couple answers here. 5 and 6, negative 1, and are there more on the next side? Nope. So if you want to try those two on your own, you can. So first step, set it equal to 0. Attempt to factor. Well, your first thoughts for 30, when you have choices of 1 and 30, 2 and 15, and 5 and 6, oh, and 3 and 10, lots of choices, should always be the two that are closest together. And since they do make 11, then you can go ahead and just finish this without using the quadratic formula. So on your homework tonight, it's going to say use the quadratic formula for all of them. You don't have to. You can always use the method that you like best. So you might only end up doing quadratic formula for a few of them. Ooh, this one's already equal to 0. And if you're paying careful attention, don't forget the step of simplifying. We did a lot of that last time. So this is actually x squared plus 2x plus 1, which is factorable. If you're thinking, we sure didn't practice very many quadratic formulas for the section on quadratic formula. No, you're not going to use it that often. Factoring needs to be your number one go-to. All right, so when we were doing these problems, at what point did we know that we were going to get an I in our answer? Look at these problems and tell me, when did you realize the answer was going to have this I in it, where these didn't have an I in it? Hopefully you said right here. That's the moment at which you say, oh, there's going to be an I in my answer because I have a negative under the radical. So somebody took this concept a little bit further and named that inside portion the discriminant. So x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. This part right here, that inside, not the square root, just the b squared minus 4ac, that part right there is called the discriminant. And somebody said, look, if that discriminant comes out to be negative, I know I'm going to get an I in my answer. And if there's an I in the answer, then that means that there's not a real x-intercept. So the parabola must go either above or it could go below. But it's not going to ever hit the x-axis. As long as the discriminant is positive, you'll get two real answers. I don't know if it's going to be factorable or not factorable. That doesn't matter. All I know is that it's going to have two positive answers. Now, sometimes you only get one number underneath there, or you get a 0 underneath there. Think about what happens if this is 0. If you have negative b plus or minus 0, then pretty much this goes away, and you're only left with one answer. So you don't have a plus answer and a minus answer anymore. When you only have one answer, that's because the graph bounces right there. And you guys see what that one answer is? Negative b over 2a. You have found the vertex. It's like a giant puzzle. By the end of the year, all the pieces are going to fall into place. So let's do an example of that. So if this were my problem, you could do out the whole thing. You could sit there and say x is equal to negative b plus or minus the square root of b squared minus 4ac. But the argument that is being made here is that you don't need all of that. You only need to find the discriminant. So just this little inside part, the discriminant is just the 36 minus the 4ac, which comes out to be 36 minus 40, which comes out to be negative 4. So you could do the whole thing and you would see the negative 4 under the radical, but when they ask you for the discriminant, your answer had better be just the negative 4. A little fussy about that. But what does that mean? Well, it means that you would have had a negative under the radical, which means this doesn't cross the x-axis. So there are two imaginary solutions. That's what that negative 4 tells us, that there would have been a negative 4 under the radical. So for this next one, let's just find the discriminant. Opposite, or b squared minus 4ac, which comes out to be 0, which means that there is only one solution, and it's real. One real solution. Because if you had been doing negative b plus or minus, and you'd put that discriminant underneath there, then you would have gotten rid of the plus or minus, and you only would have had one answer. But you don't need to do all that work. You can just look and see if the discriminant is a 0, you can picture the rest of it in your head. And last one, the discriminant is equal to b squared minus 4ac. Notice the numbers are really close, 10, 9, 8. And yet that little bit of a change really changes things. Now 36 minus 32 is 4. So the discriminant is 4, and that means that there are going to be 2 solutions, 2 real solutions. Why? Again, because this would have been this, and then you would have simplified it, and then you would have had 8 over 2 or 4 over 2. You would have found 2 real answers. So just to practice completing the square again, I'm going to rewrite this as y is equal to x minus 3 squared. 3 squared would give me a 9, so I have to subtract 9, which would be plus 1. Y is equal to, again, x minus 3 squared, which would mean I need a plus 9, but then I'd have to subtract 9. In other words, this one was already ready to go. Y is equal to x minus 3 squared. To make that square complete, I would need a 9, which I don't have. But to counterbalance that, that part goes there, and this becomes negative 1. So graphically, what's happening? The green one is, give me a second here, is over 3 to the right, and then up 1. And it has 2 imaginary solutions because its discriminant is negative 4. But the next one is x minus 3 squared plus 0. So the red one actually touches right there. See how it only has one solution? It's been moved to the right 3 and not up or down at all. So it has exactly one solution. This one, the blue one, x minus 3 squared minus 1, looks like that. And see, it's going to have 2 real solutions. Okay, so a little mid-lesson summary here. These are now your methods. Now we have learned all of them. I will never teach you another method for solving a quadratic equation. Graphing. This is not going to be your method. Nobody graphs just so they could find it. Using the square roots. So whenever you can get it down to just something squared is equal to a number, if it can just be x, or it can actually be like x plus k. Like it doesn't matter. If you can get it down to something squared, then you can do that. This is the one where there is no x term. You can isolate the square. Factoring, this is your big one. Completing the square, some of you will never use again in your entire lives after chapter 3. You'll have learned it, won't use it, and that's okay with me. But all of you will have to use the quadratic formula when you can't factor. Some kids use the quadratic formula for every single equation, but their life is slow and boring. So no, it just takes a long time. You definitely don't want to do that. Okay, we do have a couple word problems today to finish up. So the function h is equal to negative t squared plus h0 is used to model the height of a dropped object. This is not a made-up equation. This is a real physics equation. But for an object that is launched or thrown, an extra v sub o term must be added to the model to account for the object's initial velocity. So in other words, if you were just standing and you just dropped something, then the only effect on it would be gravity. But if you actually threw it down with some kind of force, not just let go with your hand, then it would use this equation because it has some kind of initial velocity. In both cases, this is the initial height. And this formula gives you the height over time. So we'll do a problem together and then you can see. Although if you feel like trying it on your own, this is 0.173 seconds. Go for it. In a volleyball game, a player on one team spikes the ball over the net when the ball is 10 feet above the court. The spike drives the ball downward with an initial vertical velocity of 55 feet per second. How much time does the opposing team have to return the ball before it touches the court? So we have our net, right? And this ball is 10 feet above the court. Oh, I don't know what a volleyball. Shouldn't have drawn it. I have no idea what the emblem is on a volleyball. No idea. All right. So right now we're 10 feet above the court. The initial velocity of the spike is going to be 55 feet per second. So I can write in a formula that will tell you its height at any time. Its height is going to be modeled by negative 16. By the way, that 16 is the force of gravity on it. That's what's pushing it down. It's negative because gravity is a downward force. Negative t squared. And the spike drives the ball downward. So this is also a negative velocity. Negative 55t. And its initial height was 10 feet above the court. So this is the equation that you can use to tell me the height at any time t. They want to know how much time does the opposing team have to return the ball before it touches the court. What is the height at that moment? 0. This is a big fancy way of saying I want to know t when the height is 0. When is that ball going to touch the ground? Do you think that this is going to be factorable? No. It's not, because we're in the quadratic formula section of the book. So, we're going to have to do it out. So t is going to be opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. Now this is a lot to plug into your calculator. So I'm actually going to do it for you, and you're going to love it. There's actually a very easy and cool way to do it. So to type in the quadratic formula, your first step is going to be to hit alpha F1. See that green F1? And it gives you the choice of making a fraction. So it's saying, do you want a numerator over a denominator? So you just hit enter. There you go. And now I'm going to do 55 plus, you can't do them both at the same time, but I'm also going to get to that and how exciting that is. Second square root is above the x squared, because they're inverses. They undo each other, so they go together. Of 55. Remember, you don't have to hit the caret 2 key. You can go straight to the squaring key. Minus 4 parentheses. Now, when you do the minus 16, you're not subtracting here. It's just a negative 16. You do have to use this negative button down there. And then times 10. I use the down arrow to get to the bottom. And I do 2 times negative 16. Now, you could write negative 32 on the bottom, but if you want it to look just like you know it's going to look and just have to hit the enter button, boom, that's really nice. So there's one of my 2 answers. Remember, there's going to be 2 answers. It's a parabola. To get the other answer, this is so cool, you ready? Hit second, enter, and it rewrites everything that you just did, and then you can just go back and change that plus to a minus. This is not the minus down here. It's not a negative. It's a subtract. And now hit enter. And those are the 2 answers. So negative 3.61 and 0.173. So of course it's your job to know which of the two answers is correct. Remember, your calculator doesn't know that this is a word problem. Your calculator only knows that it has graphed the entire equation and found the two zeros. And one of them is negative 3.61 and the other one is positive 0.173. That's the one we want. So they only have 0.2 of a second before that ball hits the ground. Okay, this number in the context of the problem means nothing. Nothing happened at negative 4 seconds. So the answer is 0.173 seconds. Good, we'll do one more. Make sure that you understand these word problems. But if you would like to try it on your own, the correct answer is 1.908 seconds. You will learn more from trying it first on your own and only watching the video if you need to. So a juggler tosses a ball in the air. If you do it on your own, make sure you use nice pictures. Now he tosses the ball in the air. The ball leaves the juggler's hand 4 feet above the ground. So there's 4 feet. And it has an initial velocity of 30 feet per second. The juggler catches the ball. So the ball doesn't actually go out there. The ball goes straight up and then comes back down. So why do people always draw it like this? Because at time 0, it's at 4 feet. This is a graph of its height over time. So after 1 second, it's here. After 2 seconds, it's here. 3 seconds, it's here. 4 seconds, it's here. This is a graph over time. Even when an object goes up and comes straight back down, this graph isn't trying to model the trajectory of the ball. It's modeling its height over time. So make sure you understand the difference between those two. He does throw it straight up. So using our formula, h is equal to negative 16 t squared plus initial velocity, they said was 30, and its initial height when it left his hand was 4. How long is the ball in the air? So pretty much we want to know the time when its height is 0. Negative 16t squared plus 30t plus 4. So if this were a regular problem, of course, you would try to set equal 0 and factor. I am still going to simplify it a little bit. Why not divide everything by 2 just to make it, or by 4? No, just by 2. Makes the numbers a little bit smaller. Plus 15t plus 2. And so t is going to be opposite of 15 plus or minus the square root of b squared to 25, that's b squared, minus 4ac all over 2 times a. So you should practice typing that into your calculator. There's going to be 2 answers. I won't make you watch me type it into the calculator. The 2 answers are negative 0.0327 and positive 1.908. So the one that we want is this one, the positive 1.908. So obviously my graph was not correct. Well, these must be half seconds or something. But this one is because your calculator and this equation doesn't know that you're doing a word problem. It's just any old parabola that it's graphing. And so it's always going to find both intercepts. But in the context of the word problem, it's your job to know which one actually makes sense. All right, so we are going to take a second and make it just a little bit harder. What if I said to you that it leaves his hand at 3 feet and he catches it at 4 feet? That will produce 2 positive answers. So let me say it again. So what if it leaves his hand at 3 feet? So, you know, he kind of bends his arm, it's a little lower. So 3 feet, 3 feet, and then he catches it at 4. So like he reaches up his arm. Let's see if I can't really draw it really good. But here's 3 feet. He throws the ball, and then he stretches his arm up and he catches this one at 4 feet. How is that going to change your equation? That equation would be h is equal to negative 16t squared plus 30t plus 3. It leaves his hand at 3 feet. And then he catches it at 4. That means you don't want to know how long the ball would be in the air just to hit the ground, like he drops it. He's a juggler. He's not going to drop it. He's going to catch it. Let's say he catches it at 4 feet. How would this problem be any different? That it's not equal to 0. So it would still be your job to make the first step, set it equal to 0. Okay? Okay. Last one. A geometry application. Find the value of x. So first of all, you do need to know, put this in your appendix if you don't know it, that area is 1/2 base times height. So area is equal to 1/2 base, which is x plus 1, times height, which is 3x minus 7. If I know the area is 8 feet, then I can solve this. Factored form is only useful when it's equal to 0. Now, my personal first step would be to multiply both sides by 2 to clear that fraction. Although I have to tell you, a lot of people do this wrong. Think about this for a second. If I said to you, what is 3 times 2 times 4? What is the answer to that? All right, hopefully you said 24, but you didn't multiply the 3 by the 2 and by the 4, right? Well, similarly, you have 4 things being multiplied. I'm going to pick these 2 to multiply them together, okay? You don't distribute. This 2 does not affect every single one of these factors. You can just let it affect one, and you can pick which one. Just like if I wanted to do first 3 times 4 and get 12, and then do times 2 to make 24, that would have been okay too. Any 2 of the factors can be combined. So I'm going to combine these 2. And then I get 16 is equal to x plus 1 times 3x minus 7. So I do want you to clear fractions, but I want you to do it correctly. Sometimes people accidentally give that 2 to everything, and it doesn't. Factored form is only useful when it's equal to 0. So I am going to have to multiply this out. First, outer, inner, last, and now I can set it equal to 0. I'm going to combine those 2, minus 4x, and when I subtract 16, I get minus 23. Of course, it's not factorable. Normally, I check a little harder, but we are in the section of your book on quadratic formula. So negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So again, I'm not actually going to make you do this on your calculator, but you're going to want to type it in once with the plus, and when you do that, you get 3.515. It's actually 3.514667, but when I round to 3 decimal places, remember always 3, I'm going to go ahead and make that a 5. And then when I hit second enter, I can go back and just change that to a minus, which is great, not having to type in the whole thing again. And I get negative 2.181. So since x is referring to a distance, it's going to be the sides of the rectangle or the triangle. I certainly do not want the negative answer. So your final answer is going to be 3.515. And that's it for section 3.4 on quadratic equation. Have a great day.